what you have is this division of two fractions, so we're going to invert and multiply. So the fraction on the left, we're going to rewrite it but factor it. So the first is the sum of two cubes, so we're going to factor it into two factors, a binomial and a trinomial. The binomial is just the sum of the two terms being cubed, so y and a plus 2. And then the trinomial will build from that outside in, take our first term and square it, take our second term and square it. And then on the inside, we're going to take the product of those terms and change the sign. So minus 2y is the inner term. Okay, and then the 6y to the fifth stays as it is. We're going to invert and multiply. So the y squared minus 4 gets moved to the denominator. It is the difference of squares, so I'm going to factor that into the sum and difference of the terms being squared, which are y and 2. So the sum and the difference. And then the 5y to the fourth gets moved up to the top. And once I get it set up in this form, I can now cancel any common factors. The y plus 2's cancel. These 4y's cancel with 4 of these, leaving your result here along the top, the numerator, 5 times the quantity y squared minus 2y plus 4, all divided by, in the denominator, I have 6y and a y minus 2. So here is my simplified form, can't be reduced any further. And when I look at my domain restrictions, I look for any canceled factors in the denominator and any uncanceled factors in the inverted fractions numerator. Okay, so there's no factors up here, so I'm just looking at canceled factors. I see the y plus 2 gets canceled. That means y can't equal a negative 2. That's not apparent in the simplified form. And nothing else gets canceled completely from the denominator. So that's the only additional domain restriction that you would have for this problem.